So welcome back everyone. Today we will discuss another named reaction, that is aldol condensation. Aldol condensation. What is aldol condensation? It is famous, and the specificity of this reaction is it is given by only those aldehydes and ketone which contain at least one alpha hydrogen atom. So it is given by only those aldehyde and ketone which contain at least one alpha hydrogen atom. It is given by those aldehyde I am mentioning over here. Otherwise aldol will always applicable only for the carbonyl compounds. If we are using the ketone, it is given by those ketone which contain at least one alpha hydrogen atom. Then we are having another named reaction that we will be discussed, named as ketol condensation. So here we will discuss with the aldehyde carbonyl. I hope you know what is carbonyl compounds. Carbonyl compounds are together aldehyde and ketone. We called them as carbonyl compounds. Okay, we called it as carbonyl compounds. So C double bond O bond is the carbonyl group. If it is aldehyde group, then one valency is satisfied by the alkyl group, other is the hydrogen. And if it is ketone, then both the valency are satisfied by the R group. That I will discuss in the aldehyde and ketone chapter, carbonyl group. Now it is given by those aldehydes which contain at least one alpha hydrogen atom. All right, now the thing is, what is alpha hydrogen atom? Do you aware of this thing? What is alpha hydrogen atom? Alpha hydrogen atom is that hydrogen atom which is directly attached to the alpha carbon atom. Now what is alpha carbon atom? Alpha carbon atom is that carbon atom which is directly attached to the functional group. So before moving on this topic, we should know the key concept of alpha hydrogen atom and what is alpha hydrogen atom is exactly about. So alpha, the carbon atom that is directly attached to the functional group. If any of the functional group is there, alcohol, phenol, or carboxylic acid, ether, even aldehydic group or ketonic group, any of the functional group is present and the carbon is directly attached to the functional group, the given functional group, then it is called as alpha carbon atom. It is called as alpha carbon atom. Getting? So it is alpha carbon atom. Now we have to know what is alpha hydrogen atom. So the hydrogen atom which is directly attached to the alpha carbon atom. Now you know the alpha carbon atom. Alpha carbon atom is called alpha hydrogen atom. Now here we are done with the concept of alpha hydrogen atom. Okay, so I hope you are getting this. What is aldol condensation? Firstly, the specificity of aldol condensation is it is given by only the carbonyl compounds, aldehyde or ketone. So it is given by those which are having at least one alpha hydrogen atom. Alpha hydrogen atom we already discussed. Now let us start with the reaction and its mechanism. So acetaldehyde is one of the aldehydic group. Acetaldehyde, or we called it, the IUPAC name is ethanol. al. All right, it is ethanol. So al is for the aldehydic group. So ethanol or the acetaldehyde is the type of organic compound which are having the alpha carbon, and if alpha carbon is present, then obviously there will be the existence of alpha hydrogen atoms. So is it applicable in aldol condensation? Yes, it is applicable in aldol condensation. Now starting with the reaction, CH3 C double bond O single bond H. Can we write acetaldehyde like this? Yes, obviously we can write CH3, it is methyl group, C double bond O single bond H. So it is acetaldehyde, the same thing that is written over here. It is ethanol. Now it is given by those aldehyde and ketone which contain at least one alpha hydrogen atom in presence of dilute base, whether it is NaOH or any of the base you may take. Now CH2, CHO and H. Why I write it over like this? Is it any trick applicable? Dilute base, dilute NaOH, sodium hydroxide, KOH, or you may take barium hydroxide. So acetaldehyde, again the 2 moles of acetaldehyde in presence of dilute base. Now what will happen? Firstly, you should know that I deliberately write this H like this because it is the acidic one. This H is acidic one. So it acts as an electrophilic group and it acts as a nucleophilic group. Why this will act as a nucleophilic group? That I will discuss during the mechanism. So what will happen? CH3, CHOH, CH2 and the CHO. Here you can see this H will attack on the O group because as that I will discuss in the mechanism. Now this product is it the product? It is the intermediate that is always formed in the aldol condensation, and it is the aldol product. Why aldol? Aldol means aldehyde and ol means what? It is the alcoholic group. And then with further heating it will remove. If you not heat this aldol product, then the aldol will be the form, but the named reaction is not complete because the name of the reaction is condensation. It involves condensation, that is removal of the water. So water is removed, then what we are having, the main product is CH3, CH double bond CH and CHO. So if we want to give this IUPAC name nomenclature, if we are applying the IUPAC nomenclature, then the number is starting from the functional group. So mit ith prop but, it is but 2-ene because the double bond is present at the second position. But 2-ene 1-al. Al stands for the suffix of the aldehyde. So it is butane 2-al. Alright, or generally it is also known as crotonoaldehyde. It is crotonoaldehyde. The another name of butane 2-al is crotonoaldehyde, or you can call it as unsaturated aldehyde. Alright, now we will start with the mechanism. Why I have taken this H like this? Why I am saying that it will act as an electrophile and this reaction will act as a nucleophile? Why you have to heat this reaction? Why you have to condense this aldol product? That I am going to mention. Now what we have discussed right now, CH3 C double bond O single bond H, that stands for the acetaldehyde or ethanol. Now CH3 CHO again in presence of dilute sodium hydroxide, dilute base. Now see this OH, this C double bond O bond, as oxygen is more electronegative in comparison to the carbon atom. So what will happen? It will create a negative charge and the carbon atom will create a positive charge. Hydrogen are here, the acidic hydrogen are present, CH2 CHO, and this is the CH3CHO, the acetaldehyde. But here the acidic hydrogen are present and that will act as a electrophile, that is electron loving, and it will attack on the nucleophile. That is always, I think you are most aware of this concept, that electrophile and nucleophile concept. It is nucleus loving and it is electron loving, so it will attack on the electrophile. And what will happen? The same thing, now we are left with the CH3, then as C single bond, because the bond polarity is maintained, so as to maintain the polarity, the bond will be the single one and the H is attached, so it will be OH, and one H we are left with this, and the another one, this chain will be add up, CH2 CHO. Now are you getting how aldol is formed? Aldol is formed in this way. As oxygen is being more electronegative, it will acquire a negative charge and it will acquire a positive charge. This negative positive and this electronegative difference that I will discuss in the general organic chemistry. So here we are having the aldol product. Now we have to condense this aldol product. What we have to do? We have to condense this, that we have to remove the water, otherwise aldol condensation won't be completed. So in presence of heat, what happened? This OH and one of the H from this carbon atom, not from this carbon atom, because here the ZZEV rule will be applicable. ZZEV rule, you will be I will add the video on the ZZEV rule. Okay, so ZZEV rule, on the basis of ZZEV rule, we are having the water. One of the H is removed from here and one OH is removed from here. Now we are having the byproduct as water, and now we are left with the main product, that is CH3. Now to maintain the valency, now the single bond will be converted into the double bond, so as not to violate the valency of the carbon atom. So it will be CH3 CH double bond CH, and what is left? The CHO. So here we are done with the watch. It is crotonoaldehyde, aldehyde, or alpha, you can say beta unsaturated aldehyde. It is alpha beta unsaturated aldehyde, or the IUPAC name. The IUPAC is methylprobute, so it is but2-ene 1-al. So here we are done with the concept of aldol condensation, with the mechanism of aldol condensation. I am repeating that as the oxygen is being more electronegative, it will acquire a negative charge. Here the acidic hydrogen are there in CH3CHO, so it will act as an electrophile and it will act as a nucleophile. So the nucleophile will attack on the electrophile will attack on the nucleophile, and it is act as a aldol. It will add up as a aldol, end up with the aldol, and then we have to condense this aldol product, otherwise our reaction won't be complete. So after condensation, after removal of water will be removed from here. OH and H you have to take from here, because ZZEV rule is applicable. So we are having the major product. The main product is the crotonoaldehyde or alpha beta unsaturated aldehyde, and the IUPAC is but2-ene 1-al or but2-ene al. Alright, so here we are done with the concept, with the theory, with the mechanism of aldol condensation. Now I will discuss the ketol condensation, that